Guys, Terence from Prysmatic Labs, super excited to be here. Thanks EDCON for having me. Today my talk is about lesson learned from Onyx Testnet. As you know, Modesha launched a couple days ago, and we sunset Onyx last week in preparation for Modesha. So this talk will discuss the lessons learned from Onyx to Modesha and some of the nice things we have implemented. So let's get started. First, I want to introduce my team. We are a team of 9. Follow us on Twitter. Check us out on GitHub. There's 9 of us. And shout out to Reddit, who just joined our team last week. And shout out to tons of GitHub contributors that we have had over the last few months. You guys have been amazing, and we wouldn't have been here without you. And if you're interested to contribute, join our Discord. We're happy to onboard you. So let's chat a bit about the history and the present on these testnets. So we started out at Ruby. So back in Ruby, it was just a local chain that simulates proof of stake beacon chain behavior. It was our earliest take on what a beacon node it was our earliest take on what a beacon node would look like. And there's Sapphire, which was launched last year. It uses 3.2 ETH instead of 32 ETH. And we only had less than 1,000 Genesis validators to begin with. But we started implementing APIs, and we want more people to build a beacon chain, and which such effort enabled Bitfly and Etherscan to build awesome beacon chain explorers on top. And there's Topaz, which was launched earlier this year. It was aimed to be mainnet compatible, and it used 32 ETH per deposit. It has slashing, it has nice optimizations. And then there's Onyx, which was launched early June. It has been running for about 2 months, and it was aimed to be multi-client compatible. It implements the latest spec, and we went through a run of audit with it. So as you can see, Prysmatic Labs went from Ruby to Sapphire to Topaz to Onyx, which is multi-client compatible. And in the parallel multi-client testnet universe, there was Shalasi, there's Wheaty, there's Autono. These efforts were largely led by Alfie. And each multi-client testnet has its own improvements, and whether it's different Genesis validator size, whether it's the amount of validated team that participated, and whether it's overall robustness. And just last week, we have sunset Onyx, and we have moved to Modesha. So there's just one testnet to work with, and that is very nice. Quick look on the Onyx stats before we sunset. There was 30,000 validators. Prysmatic Labs only ran 4,000 validators, so that's about 10% of the network. And there was 300,000 slots, 10,000 finalized epochs, and about 250 to 400 peers in the network. And in the next few slides, I'll go over some of the lessons learned, what we worked on, and some of the exciting things that happened. So from Onyx to Modesha, there was tons of improvements. There was about 2 months of the time. There were about 7 releases, about 500 issues, and 500 PRs that were closed and merged. And we were able to onboard 20 plus new contributors. So that's very nice. So yeah, so let me go through some of the lessons learned. And for those that have been running a validator, right, you may have noticed that our existing key management tool isn't the best user experience. So we have been working on cleaning that up, and we've been working on a revamp of our account management. And since the introduction of EIP 2335, so what EIP 2335 is a standardized key store directory and file format across all clients to follow a similar strategy, so it makes swapping keys between clients seamlessly. And we have been refactoring the key management tooling, so we're also making sure that new wallet tooling is much easier to use. And we have the following new key management type. There's direct, which utilize EIP 2225. There's derived, which utilize HD wallet. And there's remote, which utilize remote signing server via gRPC. They also integrate nicely with the E2 Launchpad. So yeah, check out our documentations. As part of our effort to revamp how the key management work in Prism, we also want to sharpen our toolings as well. So in particular, many users want to run the validated client in a cloud, and they want to use a remote signing server elsewhere that's able to securely store the key and sign data as needed. So in the Prism validated client, we have a gRPC client built in that connects security to a remote signer as desired by the user. So for reference, and we have put our reference implementation on GitHub. It's licensed under Apache 2. And also you can write your own remote signer server in any popular language that you want, which supports gRPC, as long as your server implements the required API schema for a remote signer defined in Prism. So one of the major improvements that's required to speed up chain synchronization has to do with how we verify block signatures, right? So the naive way of processing block is to perform sequential processing, check every state transition, check every signature sequentially. But every time we verify one signature, we incur a significant performance cost. So instead, we actually improve upon that. So we verify signatures in parallel. We batch verify aggregated signatures. We batch verify block proposer random signatures as well. So we'll need to verify once after a certain checkpoint. So this helped drastically improve the speed of initial syncing, and such improvement is very noteworthy. If you look at Alfred's latest report that you can see in that link over there, and with the full batch signature verification, Prism is almost as fast as Lighthouse, and we're confident that we'll continue improving this benchmark as we approach mainnet. So lesson 3, in Onyx, we have experienced volatile peer-to-peer messaging. So users were reporting high error rates in processing new blocks, and that seemed to affect the finality of the network. So we identified the root cause seemed to be that Prism client was getting out of sync and producing blocks that's older than last finalized block. So based on what we fixed, and we fixed the issue, and we have reflected that to the upstream spec as well. And another thing is rate limiting, right? So rate limiting and peer scoring refractory work has been started. So our aim is to make sure that Prism Beacon node is more robust and capable of performing its duty in presence of slow, broken peers. So the current rate limiting system that we have is already capable of being peers that send us requests too aggressively. And we're actually extending it to be more sophisticated in a way that how good and bad peers are detected and what actions are taken to prevent such behavior. In addition to Bain, we're also diversing a reputation system as well, which will score peers based on a wide range of different performance metrics. And we'll also throttle peer that violates carefully selected thresholds. So CoinStamp is a security, the blockchain security firm, has recently completed its audit of our Prism client, and it went over the course of 2 months. So CoinStamp examined our full code base for critical security vulnerability gaps in testing, and it found a few bugs were running the Onyx Testnet as well. And then he also gave us great feedback on end user considerations, how to minimize security risk. So you can read the full audit report here. And CoinStamp also did an excellent job. Not only it's explaining great depth on some of the vulnerabilities, he also included a comprehensive appendix which suggested best practice to reduce further attack surface. And so upon completion of the audit, we created a comprehensive tracking issue to resolve all the items found by CoinStamp. We are 70 or 95% there on addressing all the relative issues, and we'll get to 100% very soon. So lesson number 5, that we have made monitoring is very important. We have made significant improvements on monitoring. We've added better matrix, better RPC debug endpoint, and better logins and better instrumentations. We've added matrix such as drop time, so we're able to see like when the clock drift gets too wide between beacon node and validated client. So test coverage improvement, yes. So one of the feedback we've gotten when running the Onyx Testnet is that we do lack unit tests in certain areas. So we have made improvements for the last 7 releases, and that was the before and after. And you can see that blockchain package went from 36% to 57%. And that's quite nice. And please do expect that we'll continue improving this as we get towards mainnet. And in lesson 7, in Prysmatic Labs, we love postmortems. Whenever there's a drastic issues, we are always on top to write the postmortem report. This is just a good practice to have, and report documents like recovery steps. It documents the root cause. It documents all the timeline as well. So it's nice to have something to refer to. And if you're interested, feel free to take a look. So we started thinking carefully about the biggest pain points for contributing to Prism project. And we have decided to run a small community survey asking everyone about their experience running a node, interacting with Prism, and reading our documentations. And it ended up yielding really productive results. So the biggest feedback comes from the pain of learning and using our build system Bezel. And for external contributors or that want to just use Go, that was really hard. So we actually make our project Go gettable after that. And the other feedback that was resolved around account management, which we addressed back in lesson number 1. And we also got feedback such as like people want to run any sort of EDCON node, such as Nethermind, which is now fixed in our latest branch. So overall, community feedback drives really good initiative, and the people's experience with Prysmatic Labs seems to be really positive. We're really happy with it, and but by integrating, testing, understanding its complexity, I think we can do a better job. And code health is going to be a big priority for us going through mainnet. So if you have some feedback, please do let us know. So by Onyx, now this is the last screenshot that I took for Onyx before we sunset. And as you can see, it was already, since Prysmatic Labs only run about 10% of the network, and it already had problem with finality, right? So it was about 500 epochs since finality. That's about 2 days worth of node finality. And even with that, the node was still quite stable. It was still like 2.5 gigabyte of RAMs, and then CPU is fairly under constraint. And there's no gRPC error. So we're quite happy to see that. So hello, Modesha. So this is a screenshot I took before recording this, and as you can see, Modesha has been going great. It's about 8,000 slots, 250 finalized epochs, and we only run about 3% of the network. But yeah, I'm just really happy this is going really great. So you may ask, what's next for us, right? What's next for us is that we wanna be as ready for many as possible. So that includes define, satisfy beta requirements. We'll define the beta requirements. We will share the beta requirements with the community, and we'll satisfy that. And then we want to do some further audits. We want UX improvements as well. We want people to have the easiest time using our client. And as I mentioned earlier, we want to improve the test coverage, and we want to go through more rigorous integration testing. So if you're interested in any of these items, feel free to contact us. We're happy to work with you. And that's it from me. Thank you for having me, and feel free to join our Discord and ask us any questions. Thanks, guys.